Today's Math Minutes with Mr. White.
Hey, today we're going to be looking at radicals and how we can simplify them. Sometimes you've got a really big number under that radical, and it's possible to simplify the whole thing a little bit, and I've got a nifty trick for doing that. You're just going to look for pairs under the radical. Let's see how the process works.
You've probably worked with square roots before. The square root of 9 is simply 3, and the square root of 16 is simply 4. But you might be wondering exactly why that is. You could think of the square root of 9 as the square root of 3 squared, which is also the square root of 3 times 3. Now there's a pair of 3's under the radical, so we get a 3 on the outside of the radical. Looking back at the square root of 16, we know that 16 is 4 squared, which is 4 times 4. Once again, we have a pair of 4's under the radical, so it comes out as a 4.
So we've looked at the square root of 16, the square root of 9. Now let's look at the square root of anything squared. Hey, let's call it x squared. That's a perfect square. In fact, it is the same thing as x times x under that radical. Now we can make a pair out of those two, which means they can move outside the radical as an x to the first. Now we're going to use that technique with this next example that gets a little bit bigger. Let's take a look.
Let's now look at the square root of 56. Now this is not a perfect square. It does not come out evenly. Like the square root of 16 was 4, the square root of 9 was 3. The square root of 56 is a non-repeating decimal called an irrational number. Now we might be able to simplify it a bit by bringing some numbers out of the radical, and that's what we're going to be working on in this video today. It is often useful to look at the factor tree. So here you see I'm taking the number 56, I'm splitting it into 2 times 28, and 28 splits into 7 times 4, and then 4 splits into 2 times 2. So now we know under the radical we have a 2 times a 2 times a 2 times a 7. So we have 3 factors of 2 and 1 factor of 7 under the radical. As you can see, we do have a pair of 2's that are under the radical, and that's the same thing as the square root of 4, which is 2 on the outside of the radical. And then stuck inside the radical is still the 2 and the 7, which of course makes 14. So radical 56 is the same number as 2 radical 14. And here, take a look at the calculator. You see radical 56 is the same decimal as 2 radical 14. Looking at this next question, you may think I've gone insane that we would be ready for something like this. But if we simply use the looking for pairs technique, it becomes quite simple. First, let's look at the number 18. That splits into 2 times 9, and then 9 is 3 times 3. Okay, so under the radical, we have 2 times 3 so far. Let's now look at x to the fourth. That's simply 4 factors of x under the radical. Y to the third is simply 3 factors of y under the radical, and we have a single factor of z under the radical, so there's nothing to expand there. Now let's look for pairs. I do see a pair of 3's, so that can come out of the radical. Looking at the x's, I see 4 factors of x under the radical, which is 2 groups of x's. So 2 factors of x can make their way outside of the radical. Turning your attention to the y's, I see 3 y's under the radical, so we do have a pair of y's under the radical. That means we can bring 1 out, and we do not have a pair of z's, so the z cannot make its way out. Now you see we've crossed off some of the things as we went along, the things that we dealt with, and what's left behind is a 2, a y, and a z, all under the radical. So therefore our answer is 3x squared y times the square root of 2yz.
So far we've been focusing exclusively on that square root. You know, the square root of x squared, we look for a pair and out they come. There are other roots out there. Let's look at the third root of x to the third. That's 3 factors of x under the radical, and in fact, that's how that third root works, is we're looking for groups of 3 now. So look for groups of 3, you can group them, out they come as a single factor of x on the outside of the radical. So you look at what that root number is, and that's the number of factors that you need to create a group and bring them outside of the radical. See how easy that is? Let's look at an example with that cube root now.
In dealing with the cube root, we simply look for groups of 3, and then they can get out of the radical. So let's break down this radical. We have a 16. That's the same thing as 2 times 2 times 2 times 2. It sure looks like there's a group of 3 there, so I'm going to bring it out as a 2 on the outside of the radical, leaving behind a 2 under the radical. Let's focus on the x's now. I see 3 factors of x under that radical, so we can bring 1 out, leaving none under the radical. In terms of the y to the 4th, I see a group of 3, so once again the y makes its way out, but we do have a lone straggler that stays under the radical. Now what about that z squared? There's 2 factors of z under that radical. Do we have a group of 3? No, we don't. So the z-square stays under the radical. We see our answer, and you see how quickly we were able to simplify that radical with this simply finding pairs technique.
Now, I get the question from my students all the time about simplifying radicals and how to do it. I'm hoping that this video will help clear up some of the confusion for them and for you. Now, if you did find this video helpful, I'd really appreciate it if you could like the video, subscribe to the channel, and also leave your comments down below. I really enjoy reading them. All right, until next time.
This has been another edition of Math Minutes with Mr. White.